Okay, so welcome everybody. My name is Mariano Martinez Peck. I work as a software engineer for instantiations, and today I will give a technology demo about the BAS platform 2021 release and beyond. So as for the agenda, we will start with a live technology demo of BAS 2021, plus some features that are coming in BAS 2022, which I will point them out when they come up so that you are not confused. We will be looking at some of the most powerful new frameworks in BAS, like Futures and Promises, or Git and Tunnel, for example. Now, asynchronous programming with futures and promises specifically represent a different way of thinking about programming. So for that one, I will give first a brief intro before getting into the actual asynchronous demo example, okay? After that, we will talk about the long-term vision for the BAS platform, not necessarily from a feature standpoint, but from an overall point of view. We will then finish up with a quick recap of what's coming to BAS 2022 at the end of the year. And we will then finish with a Q&A session at the end. So let's get started with the technology demo so that you can see BAS 2021 in action. So the agenda of the demo itself is as follows. We will start first using Tunnel and Git to load a GitHub repository into a BAS image. We will then see an example of a synchronous demo or a synchronous example. Then we will do that quick intro to asynchronous programming that I said with futures and promises. We will follow up with the asynchronous demo itself, and then we are gonna package a BAS image with ABS, which is something new, which is automatic build support, and we'll finally run that. We will gonna deploy that image into a Linux system running on an ARM processor. Okay, so that was the agenda. So let's get into it directly. So for this, I need to go to my Windows machine, and I also will change my camera so that you can see me. And now you should be seeing a Windows machine with a GitHub repository. So the demo would be about fetching and processing data about the coronavirus. So we are going to use this coronavirus tracker API, which is this GitHub repository, which, as you can see, it's very famous. It has many forks and commits, and a lot of people it's using it. And this project has or provides you it provides you an API via kind of a REST API in which, for example, one endpoint that we are going to use is /locations, which answers a JSON with all of the locations it has data about. So it will answer Afghanistan, Albania, Algeria, Andorra. And for each country, there is also an ID associated. And the other second endpoint that we are going to use in our demo, it's /locations/6. In this case, 6 is the country ID. This is an example of Argentina, which brings you the latest data. Here we are going to retrieve this field here latest, we give you the number of confirmed cases, the number of deaths, and the number of recover. So this is slash locations slash the country ID. Okay, so the idea is that we are gonna fetch and process this data in two ways: synchronously first, and then asynchronously. So that would be part of the demo. Then we are going to package and move it into ARM and so on. So let me close this. And to start with the demo, we will start with something, because everything I am showing, it's something new. As I said, it will be new for BAS 2021 or BAS 2022. What I'm showing here, it's in BAS 2021, which has been released. It's tunnel support. And if you are a classic BAS user, it would surprise you that I have the code of this demo on GitHub. So here, if you go to source, here you can see the list of my apps, which other languages call, all the other dialects call it packages. So I can browse a package, then inside I have the classes. So for example, here I have the class I will gonna use for my demo, and as you can see, the code is all on GitHub. So how is it even possible? Well, this is because we have provided support for a file format which is called tunnel. Tunnel is simply a way to export your Smalltalk code from the image and write it in a layout on the file system that is supposed to be Git friendly. So you see here, for example, I have one file per class, and inside the class I have some metadata. So for example, you see the method have some metadata. So all that is the tunnel specification, which is the format in which we store that Smalltalk code into files that then you can version that with Git or any other control system that you want to. Even if this is something new, we have already been using this, and some of our customers as well. Some time ago, we created this vast community hub, which someone asked in the other presentation from Seth, what was our involvement with open source? Well, we created a special home for open source projects for the BAST platform. So this hub is to welcome everybody to do open source project with BAST. And all of these projects here are already using Tunnel, like TensorFlow, SUnit extensions, AWS, Gemstone, RetroGame. So all these are already using Tunnel. So we are using it, and some of our customers are as well. We also have other projects in instantiations account. So it's not just this demo, but you can see we have Tunnel here as well. We have PyGPO and some other tunnel-based Smalltalk repos. So even if it's something new, we provided some betas on the past, so we could start using it early, and our customer could use it early. So as you see here, I have the project tells you here how to load it. Here is the installation. So now I will go into a BAST image. I have here, it's a 10.01, is the latest stable, it's the 2021 release. And what I will do is I already did the Git clone for that repository, because so far what BAST provides is support for tunnel. The support for Git itself, so that you can do fetch, pull, commit, clone from the image itself, that it's planned for the future. But so far we are giving support for tunnel. So I did the clone already, and I cloned it into this directory. So now what I can do is I can take a tunnel loader, and you can do this from the graphical user interface from the browsers, but I prefer to do it from a script. So I take the path, I do git load, and it will execute it because it will take a few seconds. And I load from that path, and then I am telling to the loader be unattended. So that means no user interaction, because otherwise by default there are some kind of wizard. I'm telling use the git version. So this means that if necessary, it will use the git commit hash for versioning. And finally, I am saying load all of the maps that were found on that repository together with all the required maps. This would be the equivalent in other Smalltalk dialects. This would be like loading a Metacello group, where you take Metacello and you say, okay, load all this project with all the dependencies as well. So I have already loaded everything. So if I now go to browse the class fast demo, it's here, it's in the image, and it has been already loaded. So the load from tunnel did work, and you can do this yourself on your image, because it's already on the GitHub repository. You can see the instructions. So before moving to the next topic, I just wanted to remark that this shows the commitment of instantiations to integrate with modern tools. It helps interoperability with other dialects, and I think it helps continuous integration, even though it's not yet there. It's one step further. So I think it shows the vision of where we want to go. Okay, now that our code has been loaded, we will go to the actual demo. And we will start first with the synchronous version, which would be a little easier to understand. But since it will take several minutes, I will execute it. I have a fork at the end so that I don't block the GUI, and I can show you the code, but it will be running. Hopefully it will run, because this server that we are connecting to, the one that I show you before, sometimes it doesn't work. The server is not stable. So okay, thankfully it's working now, but could fail because it's not very reliable, this third-party server. But it's printing things on the console, so it's working. Okay, so what we are gonna do on this demo, we make a HTTP GET to /locations, which were that API that give me all of the locations that the server knew about. Then I will parse that JSON structure with our JSON reader, which is neo-JSON. And then I will iterate. For each country in the location data, I will make that second endpoint that we saw, that was /locations/ the country ID, to get the latest data of that country. So then I parse it, and then I do the processing of the data, which in this case, it will be just write it into a zip and print it into the transcript. Because again, my purpose is not to do something advanced with the processing, but I want to show our asynchronous framework. So that's why the processing is simple. So that is what we have to do. And the typical way we would do this, it's as I've shown here. Of course, you would factory this in smaller methods, and we all like short methods. But for simplicity, I thought it was gonna be easier to explain it this way. So we get the time, just because at the end, I want to see how much time I spent. I take the transcript that's here. I will be using the TTI transcript. That means I will be printing into the standard output. And then I start with my work. So I start doing, okay, let's do a HTTP GET on the slash locations. And then I will parse it with JSON, and I will fetch the locations field of the JSON data. So that would be read locations data, which will be an array of locations. So I will iterate the locations, and for each location, I will grab the country ID, the country name, province name, and I will finally concatenate country name and province just to have a kind of unique name for what I do later. So basically, I am just accessing fields, and then I will do that slash locations slash the country ID. That will give me an HTTP response. And if everything is correct, because again, sometimes the server it's not very good, so I have some stuff for if it's not working. But if it's okay, I will parse that structure, and I will access the latest. So this will answer me that dictionary that we saw on the JSON with the latest data. And with that, I can start, okay, I will create a zip write stream in which I can define this zip file with this name. Inside the zip, I will put a text file, and inside the text file, I will print the stats. So as simple like that. It's a zip in which I put a text file, and inside the text file, I print the stats. Now here I would like to do a shootout of our stream framework, which is our compression framework, which is really, really nice. In this case, you are just seeing archive and zip and gzip compression, but we support LC4, broadly, set a standard, and it's a really nice framework. As Seth commented, we ported this to Dart. So I recommend you to take a look. And then finally, I just print those stats into the transcript. So now if we watch our console, you can understand what these numbers, what it's doing. It's just printing into the standard output the numbers. And as you can see, it's going in a sequential order. So you see it's alphabetically because, oh, well, maybe not. It depends. It will go in the order of the file, which I think it's alphabetically. But it's going executing one by one. Yeah, it's alphabetically, and it's going one by one. Okay. Now to show that this is working, we can also check the zip. So here I have the working directory of this bust image, and you can see here all the files that just been generated. You can see the time, it's 2:30 p.m. And inside the zip, we have the text file, and inside the text file, we have the stats. Don't know why. It opened on a, okay. You see here the stats inside the text file. So things seem to be working on this synchronous version. And as you can see, it took 5.5 minutes to run. Okay, so why did it took that much? The problem is that this process is running synchronously. So that means, imagine the guy, the process that is running this piece of code, it's been sequential, and it would block on every IO. So let's say I am executing a country. I am here executing a country, and now I do a fetch. Here, I will be waiting for that IO to happen, and I won't be executing other countries, and I won't be executing anything else from the rest of the script either, my whole process, it's stuck here waiting on IO. So the question is then, okay, how can we optimize this? How can we be more efficient? You know, Smalltalk it's green threaded, and most people say, okay, but that's not good and things like that. But I will show you how we can optimize this and be more efficient with this kind of scenarios. And the answer is doing asynchronous programming. And for asynchronous programming, I wanted to show you our new framework with futures and promises. So let me close this, and we are going to see now a very basic intro to futures. So what is a future? A future represents the completion of a computation. So it's not the computation itself, but it's the completion of it. Okay? And what is the typical way to represent a computation in a Smalltalk? A block. So I can do is future on a block. When I do this, what would happen is that 5 factorial will be running asynchronously. So it would be more or less similar to do a fork, but it's not exactly the same as a fork. The reason it's a bit too low level to explain for the scope of this presentation, but you can imagine it does something similar. So it will just run this block asynchronously. And you could say, okay, that's it. No, if you just making one block asynchronous doesn't change anything. The benefits of this framework is when you start chaining futures with other futures so that you eventually can create a complete asynchronous workflow. So that all the time, what you do is dealing with futures. You deal with futures and everything you do is with futures. This is very common on JavaScript, on Dart, and other languages where asynchronous programming is very typical. So to see this example, I store this into a variable which I call compute factorial future. So then I could say compute factorial, then this other computation. So now this other computation will also run asynchronously. So it will be similar to doing a ES future on. But in addition, I am telling that it should be executed only after this other feature has finished. Okay, so I can define the order in which they should be executed. So they run in parallel, they run in its own, they will run with its own Smalltalk process associated to that. So it will be like a fork in the sense that it will have its own Smalltalk process. Then I can chain even more. I could say I can chain another future for compute factorial future. I could say, okay, then factorial plus 5. In this case, it was factorial plus 3. What is important here, I forgot to say, is that the argument to the block here is the return of the previous future. So in this case, this factorial would be the return of this block, which would be the 5 factorial. And then I could say, so this was the then construction. And the other one that I wanted to show, and that would be enough for the demo. So one is then, and the other one is all. All allows me to create a future on a list of futures. So that means that this future will be completed only after these ones have been completed. It's kind of a barrier. It works as a barrier. So when this future is completed, then I chain another future that will print to the transcript, I am done. And this I am done should be actually print after these two because of this construction here. So if we execute this, we should see on the console, we should see 123, which was the first, actually the second feature, then 125, and finally I am done. So something I forgot to say that is also new, which is very nice, is the brace arrays, which has been asked by customer many times. So this is here now on BAS 2021. The other thing I wanted to show is that I strongly recommend you to take a look to the class comments, because the framework is really nicely documented. You can see the length of the class comments. You can see all of the API has really nice comments. So it's really well documented. It has plenty of unit tests with a good coverage. So I recommend you to take a look. Okay, and then the other part I wanted to show features is deceptions. We have exception support. So I could say, for example, ES feature on a block, and that block could potentially signal an exception. So I have this API catch that receives an exception and a stack trace in which I can do, whatever I want with that exception. And we also have ensure. And this looks easy, but the key point here with this framework is that, sure, you can do asynchronous programming with assembly if you want to, or you can do asynchronous programming with a fork and a semaphore. But when the workflow becomes more and more complex and you start to have to deal with exceptions and things like that, your code starts to be really, really complex to manage. I would say impossible. So that's where this framework comes into play, because it has support for exceptions. It allows you to change and manage all the different features and so on. Okay, so that's it about the basic feature example. And honestly, if you got this, if you just were able to understand this part, I am satisfied, because as I said, asynchronous programming is a paradigm shift. It takes time, so it's hard to follow, and it will be a little bit harder the demo that I will show right now. So we saw that basic example, and now what I wanted to show is the asynchronous version of the COVID demo. And as you can see here, as a good small talker, I have factored out some of the methods so that I could explain this better, so it won't be exactly the same as the previous one. Okay. So let's see how we can make this process asynchronously with futures. So the idea is that it's the same. I get the time, I get the transcript, and then when I start to do things, I do it in futures. So I say ES future on the fetch. So that means this would be fork, like kind of fork. So imagine like this has been run asynchronously on a separate Smalltalk process. So this process, the execution of this process will keep going. It will keep going because it's not stuck here. This was fire and continuous. Now it says get locations feature, then I need to parse the data. So here the response is the HTTP response from here, and I parse that. And I answer the locations data. So we call this read locations future. So read locations future, then, and now I need to start iterating the countries as we did before. So I will start iterating the countries, and I would say, okay, again, ES future on the fetch. So the fetch will be running on a separate Smalltalk process. But I am saying, in the next one, I'm saying get locations, then I can do this. So once the fetch finish, I can do the rest. and the rest would be, if everything was correct, it would be a future is future on parse the data, and I will call this read latest future, because what I'm doing is actually just reading the latest data. And I would say read latest future, then write to zip, then print to transcript. And finally, I will return a future that will be completed once both of them are completed. So for the whole country, for the whole location, I will be returning this future, which means that this future will be completed once write zip is finished and once print to transcript is finished. But when this process is executing, nothing is blocking. I am firing process. I am forking processes, and my code keeps running. So, for example, if then I have a country, so let's say we are in Argentina and we are blocked here waiting on IO, that means that I have other processes for the other countries that are ready and can continue running. So when I am blocked now, I have other hundreds of smalltalk processes ready to be executed, because at the end of the day, all I have is a bunch of smalltalk processes running, and the only thing I have defined is the sequence in they have to be run. But most of them could run independently. So for example, if I am stuck here, then the futures of the next country could be executed. And the same go here. For example, if I have a country, and let's say it's blocked on the IO of the zip, like when it opened the zip file, it's blocked there. Okay, I can run this one, because the print to transcript I can execute it. So I am stuck in here, but I can continue with this one. And if it's not this one, it will be one of the other countries, and like that. So at the end, I kind of stores this future that was for a given country. I store that into a collection. So you can see I do that for every location. For every location, I store that final future on a list, so that at the end, at the very end, the completed future would basically means when I am completed would be a yes future all on all that collection, because when this future is done, then it means that all these futures for all these countries are done. And so since this is a future, I can say completed future then, and I print into the transcript how much time it took. And to see if it's worth, obviously we need to execute this and take a look to our console. So we now go to see what is happening. It seems to be working, and the first thing you notice is that they are not sorted in order anymore, because now we have a bunch of processes all running in parallel that will be executed depending on what the scheduler decides to execute. And you can see it took 22 seconds compared to the 5 minutes and a half. So as you can see, it's way faster. And obviously this code, it's a little bit harder as well. It's hard to assimilate and to understand, but I think it pays off, honestly. So with that being said, the last bit I wanted to show about asynchronous programming, but this will be much easier. It's the usage of promises. Promises are a reification. It's a new entity similar to futures, that represent a promise to complete a future in a later time. So basically, you could say ES promise new. So you create a promise, and to the promise you can say, give me the future. Okay? Then with the future, you can do whatever you want. So in this case, I am printing the number into the console, for example, but you can do whatever. It could be, for example, part of a total asynchronous workflow, like the COVID example that we saw. And then at some point later, the promise decides to complete the future as it has promised, because he promised to complete the future at some point. And when that happens, the future is completed, and therefore it will continue the regular execution. So in this case, I will be printing into the transcript once this completes. So if we execute this, you will see 42 printed into the transcript. Now, a more advanced example of promises, it's on our another new framework, completely made from scratch for BAS 2021, which is the OS process. OS process is a framework that allows you to spawn native OS processes to do something. And then from a Smalltalk, you can get notified once the process is done, read from the standard output, chain process with other process, deal with the pipes, those kind of things. So in this case, I have an example in which I say OS process starter start this Windows command that sleeps for 5 seconds. And then I'm saying on completion, then transcript show process finish. So as you can imagine, on completion, it's answer me a future, which I do something with the future. I can do whatever I want. In this case, it's a simple then instruction. So if I execute this and we count 1, 2, 3, 4, 5, we see process finish printed into the console. So how this magic happens? It's very simple, and that's the power of promises. So if we take a look to the on completion of OS native process, it creates a promise. Okay, the framework creates a promise, and if the process is still alive, because it could have been very fast and be already finished, but assuming it's already alive, the process, the native process, it will register the promise for completion. So the framework, OS process framework, will store a list of promises to be completed once the OS process, the native OS process is finished. And what returns to the customer, to the user of the method, is the future associated to the promise. Again, OS process knows nothing about the future. All it knows is the promise. So later, when a process is a native process is completed, the virtual machine will execute a method, and that method will execute another method, and at the end, what would happen is that this method will be executed, which is called fulfill completion promises. And it's very simple what it does. It says, okay, give me the list of promises that I have stored that I need to notify once the OS process has been completed. And then iterate those promises and say, okay, for each promises, complete the promise with self. This complete is what completes the future associated to that promise. And again, OS process here knows nothing about the future or what is going on with the future. The customer defines what it does. So OS process knows nothing about that I'm doing this, for example. All it does is to complete a promise. So it allows this decouple from the framework and the user of the framework. And that's a typical usage of promises. The other one is when you have an existing API, which is synchronous, and you want to provide a asynchronous API. That's another typical case where promises are used. Okay, so that's it about our new framework of features and promises. And now what I wanted to show you is, let's say we want to make an image with this demo. I want to package, I want to deploy an image with this demo. So if we go again to see the class, you see that I have, no, sorry, I already showed everything I need to show. So to prepare an image for deployment, BAST provides what is called the packager. The packager allows you to bootstrap an image from scratch, then load your code, and finally reduce it, remove everything you don't need, and just keep the code that you actually need. And that's called the packager. And what we did in BAST 2022, so this is not BAST 2021, but it's on the upcoming release. It's, no, sorry, wrong class. So far, the way people deal, the customers, the way customers deal with the packager, it's through a headful kind of wizard component. And what we wanted to do, it's in the same vision of going more friendly with Git and more having more integration with modern tools. We wanted to make it easier for continuous integration to run the packager. So we have done something which is called the automated build support, ABS, automatic build support, in which you can give a build specification, and then at the end you can just send the message build. So you need to tell a name, you need to tell where is the map that it needs to load. Then you need to give some packaging instructions. Packaging instructions are very easily, but for example, you can say, okay, what is the startup method that you want to run at startup? So in this case, I'm saying run this fast 2021 demo async process copy data. So this will be executed at the startup. And I can also tell which apps do I need to include. So which applications or which packages do I want on my image? And that's practically all I have to say. So I will execute this because it will take a few seconds, and I will explain why it's happening. So here what it's done is creating, it's bootstrapping an image from scratch for Unix. As I say here, I want this for Unix, so it just bootstrapped an image from scratch. Now it's loading my dependencies. It's loading the features that I needed from this image. Then it loaded my maps. So it loaded fast21 demo runtime. So that's my code. And finally, right now is running the packager, which, as I said, running the packager, it means to reduce everything that is not being used by the image and generate the final ICX file, which is the BAST image file. The process has already finished. So if we now go to our working directory, we should see here the fast 2021 demo ICX that was just generated. You can see the time it has been just generated. And in my opinion, the awesome part here is the size of the resulting image. So the resulting image is less than 2 megabytes. And compare that with the development image, which is 20 megs. And this runtime that we generated, it's just less than 2 megabytes, and it was done automatically. I show you, all I needed to say is just what packages did I wanted, and what's the startup code, and that's it. That's it. All the rest was magic of the packager. So I think that's pretty cool. So okay, we have our Smalltalk image ready to be run on a Unix platform. And for that, what I will gonna do is I have here with me, it's next to me, there is a Raspberry Pi 4, which is running, of course, on ARM processor. And what I will do is on the left side of the Total Commander, I am connected into the via SFTP. I am connected, so let me just show you. So here I am connected. I am connecting to my Raspberry Pi, and I will go to Home, Pi, Instantiations, BA 1001, and here what you will see it's a deployment of the virtual machine. So first, let me remove all of the zip files that they were created on previous runs. So let me remove those. Under Bean, you can see here we have all the binaries of the virtual machine. These are just support directories. Depending on what you use, you might need some of these directories, but the most important is Bean, where you have the virtual machine. And then we have the image, which again, this one is from previous runs, which I will remove. And then we have an ini file and a bash. So let me copy the image file from my machine into the Pi, into the Raspberry. And now let me show you the bash. The bash is really simple. The only thing it does actually is just run our virtual machine, which is ES-NX. NX means no X. So this is actually our headless virtual machine. And all I have to say is what is the image that I want to run and what is the ini file, which is just some basic configuration for the image. Okay, so this is the bash. It's really simple. I move the ICX, yes. So now I will connect via SSH into my Pi. Okay, you can see Unai, you can see I am running on ARM. And then I will go CD instantiations, BA here. You can see that's the directory that we were looking at. And now I will run. And hopefully the server it's still running. So I am crossing my fingers it's running. Yes, it is. So now it's the same demo, the same code that was running on Windows, on Intel, is now running on my Pi, and with a 2 megabytes image, and it took 14 seconds. So it took even less than my Windows, and that's because I'm running virtualized, but still it's an amazing performance. And part of the reason of this is because until now, we have been showing ARM in betas and previews of previous releases, but at that time we were running a slower virtual machine without the just-in-time compiler and things like that. Right now, and what is coming to Bust 2022 at the end of the year, it's a full supported ARM platform, and that means that we support ARM32 bits, ARM64 bits with our bleeding edge VM. So that means we have the just-in-time compiler and everything running. It's the same VM that runs on Windows and Linux on Intel, but running on ARM. And that's what you are seeing, here, and what you will see in the upcoming release. So I think this is pretty cool. So that was the end of the demo. So now I will get back to my slides. So let me put again my slides. Oh, I went from the beginning, sorry. Okay, we are here. So what I wanted to say now is that I know it's a lot to digest. Asynchronous programming, it's a paradigm shift. It changes the way you think about program execution. And it takes time to actually get it. We cannot rewire our brain in 20 minutes. That's the nature of a paradigm shift, actually, that it's really hard. The good news is that the example is on GitHub, so you can experiment with that. This presentation is being recorded, and it will be uploaded to YouTube, so you can even watch it again. Of course, you can always feel free to reach to us if you have, questions. So hopefully the demo leads you to the question of like, okay, but what is the long-term vision of BAST? And the reality is that customers take priority, as simple as that. Part of Instantiations being a commercial smalltalk provider, it's being receptive to our customer needs and not just focusing on our vision. If our customer need certain features, we will listen and try our best to include them. In addition, we can also work with them as part of custom development effort to implement features that are tailored to their exact need. So that's also a real possibility that we have done and we continue to do with some customers. Okay, so even if customers take priority, which I already said, we obviously have our own vision and that we try to fulfill. And that is to solidify BAST as an important part of the broader software development ecosystem. So that means we want BAST to have an important seat on the table. We want BAST to continue to be a premier platform for software development that integrates well with modern system methodologies and technologies. And the key word here is integrate, because nowadays a system does not play alone anymore. The communication and integration with other frameworks and libraries and technologies has become something critical for software development platforms. And that's why we have been focusing on technologies like WebSocket, gRPC, HTTP2, CSI, REST, OS Process, Docker, ARM, Tunnel, just to name a few. It's not that we woke up and we randomly selected those projects. Those are to fulfill our vision as much as we can. And finally, is to keep a focus on both thick client applications as well as server-based Smalltalk applications that potentially even without a Smalltalk-based client. Think like, for example, a JavaScript front end or a mobile application. And then you can still use BAST on the back end. and with some communication like REST and JSON or something else. So I think both architectures are really important, and we want to focus on both of them. For more details about BAST and the latest news about it, I strongly recommend you to take a look to our website, and particularly these links. You can also follow us on social media like Twitter and LinkedIn if you want to. So the question is, what are we working now towards this vision? The truth is our BAS platform 2021-22 release coming at the end of the year has an insight of what we are doing. We have a whole new Unicode support framework, which has been asked by customer many times. We will have official support for ARM, as I already talked. And this is important from any aspect. It's important for IoT, which I think BAS could have at least a part of IoT that could fit. Very interesting for cloud deployments. So there are servers, cloud serving servers that are already offering an ARM alternative. Like for example, Amazon AWS is already offering ARM instances, and it reduces the cost of hosting. So it's important. And the same goes for desktop. So you probably saw what happened with Apple and the M1 laptops and the chips with the M1. So I think ARM will get more and more attraction. So it's important to have a good support for that. Then we will have asynchronous streams framework as well as asynchronous zones. So these are two new frameworks that will complement the work on futures and promises. Updates to Seaside, a new Windows table view widget, HTTP2 support, WebSocket, gRPC, the automatic build support, which I show XD, but it also works for regular packaging, many more. For more details about our roadmap, you can see again that link on our website. And that's it. I don't know if you have questions. Thanks for attending. I know it was long and some parts were probably heavy. So thanks for staying. Let me know if you have questions.
Okay, so Julian just raised his hand. So go ahead and ask.
Hi, Mariano.
Hello.
I have two questions, one about async and one about packaging. Regarding async, do you have any mechanism for rate limiting executions? An example of this is there are many APIs that allows you to do X number of requests per second or per day. Do you have any feature or have planned something to limit that, or do we have to implement it ourselves for the time?
Could you repeat the first part of the question? Sorry.
Do you have any mechanism for rate limiting the future executions?
No, for the moment there is nothing. We are focusing on the building blocks
Okay.
of the technology. This would be a foundational aspect that, on top of futures there are streams and there are zones. So there is plenty of things that could be built on top of that. We have thought about, for example, you probably saw the HTTP2 support that would be built on top of futures. And the same goes, for example, if we want to do an asynchronous HTTP client or anything that goes on that direction, we can now potentially do it. The only usage of futures and promises that had been released in the last version, it's the part I show on OS process. That's the only real usage that you see from BAST itself. about futures so far. For Bash 2022, we have plenty of others. But yeah, I think it should be easy to implement what you said.
Okay. And regarding packaging, how do you deal with pop-ups or mainly errors during loading or packaging? Those are kind of Git breaking
Yeah.
CI builds right now, and
Yes.
sometimes hard to handle.
Yes. So far, the easiest way we found to do that, it's a little bit hackish and not ideal. But as you can see, we are going step by step. So I'm sure we will get there at some point. But what we are doing now is we are basically running our CI with development image, not with a package image. We are running CI with development image, and the development image, it's actually running with a fake X support. I don't remember the exact name. It was XR. I don't remember, but it's
Virtual frame buffer.
yes, I think that one.
Buffer.
Yeah,
Yes.
I think it was that one. So the GUI actually appears, but it does not block us to continue doing the work. In an ideal world, what I would like to, and that would be my vision, would be to decouple the GUI completely, so that you can even do it from a package runtime headless image. So that would be my goal. So far, we are still using a development image. But that was a good question. So thanks for bringing it up. Okay, any other question?
Yeah, I have one if I can.
Yes.
Okay, just technical things, because it's not clear exactly. When you show the code on the asynchronous stuff, I don't understand the meaning of the first futures, because or I don't understand the future, or I don't understand why there was the first one. If you have the code, because I don't understand if it is needed by the way the futures are done, or it's just there for presentation scope, but it's not necessary.
Okay.
The first one, you see the SSP HTTP client. Why make a future here if you have to, in any case, you have to wait for the end before to start? This could be a synchronous operation.
Yes, that could be a synchronous operation.
Okay, because the futures would make sense when you have many parallel operation in the core of the computation, when you ask for the city for every nation. But okay, because I don't know, I suppose it was necessary for continuous the work on the stuff. So
no,
it's not necessary. Okay,
it's not that this part, it's not completely necessary and won't change the total effect.
Yeah, that's why I suppose, but I was not sure why it was there. Okay, thanks.
And I could even have used the same feature for both of them, for example.
Yeah. Sure.
Cool. Yeah, it takes time. I mean, I am making this presentation right now, and it looks like I know about it, but it took me quite some time for me to get it. So
I work in Node also, so it's not a problem about the asynchronous stuff. So that's the problem is that it looks like all the JavaScript way, and probably the way Java is doing now, that is async await, result in clearer code. That this is looks the first version of the old version of Java. Yeah, but it's fine. Very nice.
Thank you. And again, you can also grab it from, I don't have it here, but you can grab it on GitHub. The code is on GitHub, and you can even play with that. You can take it and take a look, experiment. I put some transcript shows here and there that helps understanding a little bit how the flow is, but I didn't know if I would have time for that, so that's why I didn't show it. But yes, if you are familiar with other asynchronous frameworks, be it on JavaScript, on Dart, or even more if it's an A+ spec, then it should be trivial to get this one.
I use a fork at the moment as semaphore, so this small talk. That's
yes.
what I have to force it to do. Yeah, thanks.
Yeah, imagine doing this example with semaphore and fork.
Yeah.
So it's
not easier. Yes.
yes.
It's making
Exactly.
sense. Yeah.
Anyone wants to ask something else? I don't see questions here in the chat.
Or if no one asks, I have still another question. Just
Sure.
related to the silicon, the new M1 and something like that. Will you work in the Apple silicon? Will we plan to do that?
In the what? Sorry?
In the Apple, in the M1, the new silicon ARM silicon, Apple silicon.
We don't have plans right now because
It's brand new.
mainly because OS X is not supported, an official supported platform of BAST, so it doesn't make sense to try on M1 if OS X itself is not a supported platform. It runs very well with Wine. I have used it many times, but it's not official. I mean, the official supported platforms are Windows and Linux. So that's why we didn't pay attention to M1. But if we would have to, I don't think it should be really hard, because our virtual machine technology is using LLVM to leverage the, for the code generation. LLVM is the one that generates the ARM instructions. So if you ask me, I don't think it should be super difficult once you already have ARM v7 and ARM v8 already running. But I don't know more than that. Okay, so I guess that was it. Again, I hope you enjoy, and thank you for staying this long session.